Hi everyone, so today we'll solve a problem using HEFT scheduling. So in the end, you'll be able to schedule the given tasks to the different processors which are given. So let us take a simple example as shown in the figure on the right hand side, and let us try to solve this using HEFT. So there are two steps which I've divided into solving this problem. The first step is to calculate the ranks RU and RT, and the second would be to calculate their earliest start time EST and earliest start time EFT. So, and it should be done on the basis of graph. So this is more like a spontaneous. So you do this as you draw the schedule on the processor. So we'll come to that later. And the first is to calculate the ranks. So let's do that. So this is a formula which I have used in order for simple understanding. So to calculate RU, which means the upper rank, you add the weight of the one which have been calculating, for which you need to calculate. For example, if you're trying to calculate this for the first node or first task, R1, so you need to add the weight of R1 and you need to add its communication cost with respect to the other task which you're trying to take measure with, and then add the weight of the other task. So we'll see this as we go on. So these formulas are quite simple. When you see the paper, it's more bigger, it seems bigger, and I always suggest you to refer paper for much better understanding. This is just for understanding how to solve the problem in few minutes, or the basic functionality behind the heft. I want to say that this technique is not developed by me, so this is just my video on the technique which is already there, so I take none of the credits for the technique. So let us calculate the RU based on the table. So in this table there are a few columns. The first column is task. So basically these are the tasks A, B, and okay, so these are the tasks A, B, C, D, E, F, and G, and the processors P1, P2, P3 are already given, and the mean weight would always be given as well. So now we need to calculate the RU and RD. So let us calculate RU. So RU, as you already know, is the upper rank. So for upper rank, you always need to come from below. That means if you take this example, you have to start calculating RU from below. That means from F, and then D or E, and then A, B, C. A, C, but G should be done before than B. So let's get on to it. So RU, F, F. Since F has no other tasks below it, so there are no other tasks which are dependent on F. So you need to, in such a case, you need to add the processor execution times. That means the P1, P2, P3, which is given here, but this should be done for the F. So that means you add 3 plus 2 plus 1 by 3, which is done here. So 3 plus 1 plus 2 by 6. I'm sorry, it's 3. My mistake. So it'll basically get 2. I hope you understood that. And let us go for the next task. So either you can go for D or E, or you can always do G as well, but I'll go with E. So for E, how do you calculate is basically again the weight of E plus communication cost between, okay, let us see from the figure. So E should be done before F, so the communication cost between E and F should be taken, and then you add the weight of F like the formula says. So pretty simple, right? So weight of E plus communication cost between E and F, and then weight of F. So if you see it from the table, weight of E would be 1, and communication cost between E and F would be given in the diagram, which is already again 1, and then the weight of F, which is 2. So 1 plus 1 plus 2 is 4. Okay, so the next task would be D. So it's same again, weight of D, and since D has a lower node which is F, so calculate the communication between the D and F, and you add the weight of F. So this is pretty simple again, right? So you just get the table values from the table for weights and see the communication cost from the diagram, which is 3. Okay, so for the other ones, for the C, it would be simple again because C has only one task below it, like a direct below. So it would be simple again, weight of C plus communication cost between C and E, and then weight of E. But let's come to a situation where there is one upper node and 2 downward nodes. That is in case of B. So B has 2, that is E and G. So how do you calculate upper rank in this case? So you calculate the upper rank for both of this. That means you add weight of B, communication cost between between the B and E, and the weight of E. This would be with respect to E, and you do this calculation again for with respect to G. That you say add weight of B and the communication cost between B and G, and then weight of G. So this is what I've done here. And if you get the values from the table, the answer would be 11 and 8. So in the formula, as you can see, there is something called max. That means, so whichever has the maximum values or the maximum maximum outcome, so you take that value. So that's why we consider rank of B with respect to G and not with respect to E. Okay, all right. Next, yes, I have written this here. So since the rank of B with respect to G is greater than rank of U of B with respect to E, you need to choose a rank of B with respect to G. Okay then, what about the remaining nodes? That is G and A, I believe. So G, as you can see, does not have any other task below it again. So it's basically you add the processors for G, that is 6 plus 4 plus 2 by 3. So you need to do the average again, which you did this for F. Do you remember it? Yeah, so you need to add all those and take the average. So that would be 6 plus 4 plus 2 and divided by 3. So that would be 4. Okay, and the last remaining would be A. A would be, so A has only one node below it, that is, it has a direct connection between E and A. So you pretty much use the formula and come up with the RU. Go ahead and try and check if the answer is correct or not. So once you do that, you need to fill the RU table. So you just, RU column. So you need to just fill these values in the table. So you do it as you go on, that would be much easier, but here I'll write it anyways. So for F it is 2, for E it is 4, and for D it is 11, and C it is 10. Alright, for B, yes, we need to take B with respect to G, that is 11 again. 11 and A and G. So G was 4 and A was 8. Okay, G is 4 and A is 8. Alright, so this is almost half the problem. You do not normally need RD values for calculating the EST and EFT to draw the final schedule, which I'm going to draw here. But anyways, let us calculate that as well. So as you can see, the RD formula is a little different, or fewer values. So let us do for RD. As you can expect, we started from below for the RU, right? So you do the same but vice versa for RT. That means you need to start from above. So for A, B, C, and D, there are no other tasks above these nodes. So in the rank D would be 0 for all these of the tasks. So for A, B, C, D, you can just simply put 0 and we basically calculated the RD values. But for E, F, and G, as you can see, E, F, and G, they have dependency on some other nodes, so we have to do it with respect to them. All right, we'll start with our D of G. Okay, RD of G. So what does the formula say again? So it says you add the weight of 2, which is the other node which is dependent on, and take the communication cost. So RD of G would mean you take the weight of B and add their communication costs. So weight of B from the table is 2 and communication cost is 5. So you add weight of B and communication cost between G and B, which is 2 plus 5 is equal to 7. So write this back. For G as 7. Okay, let us do for E. So RD for E, right? So from the diagram you can see it depends on 3 of the nodes before it, but you need to see the maximum communication cost is with respect to C, or it's C. So you just need to do it with respect to C and we'll get the maximum one, and you do not need to calculate again with respect to B and A. So this means you add the weight of C, which is 3 from the table, and the communication cost, which is again 3 here. So you just need to add 3 and 3. So I'll just basically write it down instead of writing whole thing. So it would be 6. The remaining one would be F, right? Okay, we'll keep this in the table. Where was it? So 6, and the remaining would be F. So from the figure, as you can see, it is with respect to D and E. That means it depends on these two. So which one do you take this time? Yes, it is D, because the communication cost is higher for D. So you basically need to add weight of D, which is 6 here from the table, and you add the communication cost, which is 3. So 3 plus 6. I'm not writing the formula, guys. Hope you understand this. You can always refer back and where I've written so that it would be easier. Okay, so now you basically have the table now. Okay, let me write this down. 9. So how do you do the schedule, which is the main part? Okay, so this is a simple one which I've taken. So let me take how many processes are there. So it's P1, P2, and P3, right? Let me write it down below, above. P1, P2, and P3. This is more neat. Okay. Alright, how do you select which task needs to be scheduled first? So in HEFT, you take it with respect to RU, and which is the maximum RU. So the maximum here is B or D because it's 11, which is the highest among all the other RU values. So you can start with either B or D, but in this case I'm taking with B just because. Alright, so if we come to the scheduling, the P1, P2 and P3, they're already at time instant 0, right? So this is a starting time for B. That means it can start at 0 of all this processor. Okay, now I need to do for just a second, I'm missing a line for one of these columns, sorry. Alright, so this is done, so it's not perfect. Alright, so now you need to schedule on any of the three processors you want, but you see the processor P1 and processor P2 takes only one execution unit to complete, and P3 takes 4. So it's better we do it on the processor which takes less execution units in order to save time and in order to save the cost. So you can either schedule it on P1 or P2. So let me take it on P1 then. So this is where it is starting and it's ending because it's basically takes only one unit of execution. Alright, so now the finish time. Okay, how do you calculate the finish time for this? So basically add all the values to a processor execution values to P1, P2, P3. That means you add 0 and 1 here, and 0 and 1 here, and 0 and 4 here. So the AFT for this would be 1, 1 and 4. Alright, so how would you take the next task for scheduling? So you can take the next highest one, which is D, right? So D has 11 as its RU and it's higher than all the other values, so we take D. So when it is ready to start, that is, see from the picture here, so in the graph, so P1 is busy till 1, so it cannot start until 1. And it's important to see that B and D, or the other stuff which you need to check here, is the task does not depend on any other tasks. For example, here B has no other task from above it, so it's independent. So you do not need to check these values, and the scheduling which you did was correct. Even for D, it does not depend on any other values, any other task above it. So you can simply schedule using this EST, E and EFT. So let us start with D now. So when is it ready? From the graph you can see that P1 is ready to take the task D at 1 here. So that and P2 is ready at 0 itself, and P3 is ready at 0 as well. So can you guess what's the starting time? Yes, it's 1, 0 and 0. So now you add the the processor values here to these ones to get EFT. That would mean 838. So if you see the values here, the processor P2 would take the least time and finish earlier than all the other processors, right? So you can schedule this on P2. So D goes here on P2. So how many tasks does it unit of execution does it take? So on P2 it takes 3. So add 3 here. 1, 2 and 3. So this is D. Next we'll come to the one which has a higher ranking again, which is 10. So it is C. So when are the processor ready to take the C value? The processor P1 is not ready till 1, and processor P2 is not ready till 3, and processor P3 is ready at 0 itself. Okay, and you need to also check C does not depend on any other task above it, so it's fine. So now you add up the processor values 3, 2, and 4 with 1, 3, and 0 respectively. So you get 4, 5, 4. So P1 and P3 finish earlier compared to P2, that is which is at 5. So you can either schedule it on P1 or P3. Let us take P3 since it's free and it's ready at 0 itself. So how many tasks does it take on processor 3 is 4. I'm sorry, that was wrong. So you need to